In this graph, there is a figure and then the measurement is not actual, which means that it's within a certain range and it's nearest to 0.1 cm. So I take this as an example, 3.2. In this measurement, the next value is next 0.1 cm. The next mark is 3.3 and then the next one is 3.4. The previous one is 3.1. And then you have to understand the actual length within a certain range, you will consider it is 3.2 but not 3.3. So our boundary is in the middle between two marks, which is 3.15 and 3.25. That means if you find out the measurement is 3.2, actually it is between 3.15 to 3.25, this range. Now we look at the actual area. This kind of graph, how we calculate the area, the easiest method is we consider a big rectangle. And then we cut out the space. That's our strategy. So the area of the hexagon is a large rectangle and then small minus the small rectangle. AFE, maybe I call this one G. And then minus BCDG. Now there are two boundaries, the minimum or maximum. We just find either one of them is enough for us to sort out the answer. So we may consider minimum area case. Imagine that you want a minimum situation. Then you want the original paper as small as possible. So for every length here, you will try to choose the lower boundary. Because 3.15, we still consider it is 3.2. So we considered AF, I take 3.15, which is the minimum value. Similar reason, 3.8, I take 3.75. And then you have to subtract, you have to cut out some area. You want to get the final minimum area. Of course, you want to cut more. That's why this part we try to consider as big as possible. For this section, 1.8, I want to consider longer one. So the longer one is between 1.8 and 1.9. So the boundary is 1.85. So we take 1.85 here. Someone say that it should be 1.84 because 1.85 we already consider is 1.9. But we're just talking about the boundary. That's why you don't find any equal sign here. It cannot be exactly equal to 1.85, but can be slightly smaller than this. If you just think that you take 1.484, then how about 1.849? How about 1.8499, something like that? So we just simply use 1.85 and then we reject the equal case. So for the height 2.0, we want to get the larger one. So it's we take 2.05. And then we just need to calculate this one. It gives you the minimum case. So we use our calculator. This is 3.15 times 3.75 minus 1.85 times 2.05. We get 8.02. So it's enough for us to sort out B is the answer. And then your task, you may be considering the maximum case. Maximum case, I want the original paper as big as possible, while we cut out the part is as small as possible. So try to get whether it's 9.1 yourself.